Hello everyone. A light spring of force constant 1 Newton per centimeter. 1 Newton per centimeter is same as 100 Newton per meter. Is stretched between two fixed supports A and B. A point P on the spring is pulled parallel to the spring. This is a point P. Point P here. It is pulled to the right by a gradually increasing force. As it is pulled to the right, more force will be required because there will be elongation and compression in the two springs. When this force becomes 5 Newton, what is the magnitude of displacement of the point P? So let us solve this problem. And before solving this problem, you need to keep in mind one concept that for a spring made up of the same material, if we use a spring of greater length, then the spring constant will become smaller, whereas a spring of smaller length made of the same material has a greater spring constant. And let me emphasize it a little bit. Suppose we have a spring like this of spring constant K and total length L, and if I cut it into two parts of length L1 and L2, then the spring constant for the first part is K times L by L1, and for the second part K2 becomes K into L by L2. So definitely K1 and K2 are greater than K because L1 and L2 are smaller than L. So let us keep it aside, keep it in mind, and then we are going to solve this problem. So if we see the two springs, they are in the ratio 4:1. So total length is 5. So the spring constant for the first part K1 will total length is 5, so this will be 5K by 4 using this formula. And for the second part K2 will be using K into L by L2. This will become L is total is 0.5 and L2 is 0.1, so this will become 5K, and K is the total spring constant, and it is given, it is 100 Newton per meter. So now next, if we see the free body diagram of point P is under the influence of an external force F, which is gradually varying. Definitely it will need to be varied because as the point P moves to the right, more force will be required. And let us say the displacement of the point P is x. As a result, this spring constant is K1, this is K2. So the spring on the left K1 will apply a pull force K1 into x, and spring on the right will push the point P towards left. So a force K2x will act to the left. So both the forces due to the springs will act to the left. And since the point P is moving without any acceleration, because this is an ideal spring, massless spring, so the forces must be balanced on the point P. So we can write F equal to K1 plus K2 into x. And if we put the values, F is given, F is 5 newtons, and K1 is 5K by 4, and K2 is 5K, and into x we have to find out. So 5 equal to, we can take 5K common, and then we will get 1 by 4 plus 1 into x. 5 will get cancelled, we will have 1 on the left hand side. So 1 equal to K is 100, and this will become 5 by 4 into x. So we will get the value of x as 0.8, 5 by 4. 4 will go in the numerator on the left and 5 in the denominator, so it will become 0.8, and divided by 100 in SI units, so meter. So this we can write as 0.8 centimeter, or this will be 8 mm, 8 millimeters. So this will be the displacement of the point P. So 8 millimeter is in the first option. So correct option is A. So you can have a look once. So the main thing is we can visualize, since the point P is dividing the total spring into two springs of K1 and K2. So main thing here was to calculate K1 and K2. In fact, these two springs are behaving as if they are in parallel with respect to the point P, because the forces are in the same direction. So that is it. Thank you very much.